The fees should be paid in the same currency. You take the good and bad that comes along with that, just as a contract. And it's not our problem, it's their problem.
Everyone, welcome at Wave-Act. Nesta and I are already super excited because today we're going to talk with Aisling Connolly. She's general lead at DFINITY, basically the foundation behind the internet computer, and she's leading core efforts of their new chain fusion and multi-chain integrations department. And she's really an incredible person by herself because she holds degrees in math, economics, computer science, and even obtained a PhD in cryptography. And additionally, if that's not even already enough, she has a strong edge to privacy. I'm really excited for this episode, and just to give you a quick rundown, we have mostly focused about chain fusion. We have talked about account abstraction, CK, and all the other stuff they're building at internet computer. So it's really exciting. I learned a lot myself, and we have really gone into a lot of specifics, also in terms of consensus, security, basically all sorts of stuff that you maybe don't find that easily by just Googling on the internet. So without further ado, now let's really jump into the episode.
Wave-Act, the Web3 software company that understands what you want.
Hey Ash, it's a pleasure talking with you. Thanks for coming on the show today. First of all, I have a really quick question for you, or let's see how quick it actually is. You have been leading the core efforts at Chain Fusion, which is a quite new development at ICP, basically Internet Computer. Would you mind sharing in what regard it's different to all these existing multi-chain cross-chain solutions already out there, from, just to name a few, Layer 0, Cosmos, Polkadot, whatever you can think of and on top of your head could give some, let's say, basic comparison?
Yeah, it's a small question. No.
Right.
But first, thanks for having me. It's very nice to hear and to talk to you today. But yeah, so the chain fusion stream of work, let's say at DFINITY and for the internet computer, it just packages a lot of the work that we've done before. So the internet computer itself is built on a lot of cryptography. We have a huge cryptographic team here. There's been like a lot of research into making like a very scalable and secure blockchain network, basically. And so inside the internet computer, there's a lot of cryptography that we use pretty much on every level of the stack. And over the past years since we launched, we've been releasing different parts of that to developers so that they can use it. So that is one side of it. We have a lot of cryptography. The other side is that we thought it would be cool if smart contracts could actually hold Bitcoin or hold Ethereum or do transactions. So instead of a particular end user interacting with the Bitcoin blockchain or different blockchains, we thought it would be cool if smart contracts could. So the cryptography allows them to have keys, have cryptographic keys that allow them to sign and generate wallets and this kind of stuff. But then, okay, it's one thing to be able to have a key and to sign, but how do you communicate with different blockchains? So with this, then we did some network integrations. So the ICP nodes also run, let's say, Bitcoin adapters, so that they always have the UTXO set. So with this, it allows to read and write to Bitcoin, sign transactions, things like this. And the same for Ethereum. So the cryptography that we use is we have a threshold ECDSA implementation, let's say. So ECDSA is the type of signature you need for Bitcoin and Ethereum. The threshold means that, okay, the key is distributed across nodes in the network. So you have this situation where it's a decentralized signature. And how is this different? So I think this allows to sign across all of Web3. So for me, the kind of main difference to, let's say, I think Polkadot and Cosmos are changing a bit now, but in the classical sense, I think they were very, very strong in interoperability in their own, let's say, ecosystem. So they had parachains and this kind of stuff. So very strong in their own ecosystem, but then communicating with Ethereum or Bitcoin or Solana or any of this kind of stuff, they needed either something like Chainlink or like Layer 0. They have different approaches. So often requires having smart contracts on the different blockchains. And then there's a question about who manages those smart contracts, who deploys them, what is the security level, this kind of stuff. And so for us, it was always kind of super hyper important to have decentralization at every level. And that the setup of this decentralization was always, let's say the keys that we use to sign across different blockchains were never whole in the first place, but they were always even generated in a decentralized way. So yeah, like really a lot of decentralization, a lot of cryptography, peer-reviewed science, this kind of stuff that gives us like security guarantees that you couldn't find elsewhere. So it's kind of the brief introduction to how it's a bit different, but yeah, lots of cryptography and security, I think, in a nutshell.
Sounds like that was quite challenging to pull that off. Let's put it that way. Would you mind sharing one of the biggest challenges or hurdles that you have overcome at ICP to develop that?
So I think one of the key innovations is, it's funny that you say it sounds challenging. If you talk to the cryptographers here, they're like, it's just threshold cryptography. This has been around for so long, what can it be? But yeah, I think sort of setting up these protocols in a distributed way is hard and it is new. And I think one of the key innovations that came from ICP is this, what we call chain key cryptography, from which all of this stuff derives. But this was, setting everything up in a distributed, decentralized way, I think was the key sort of technical research, engineering innovation that came.
I know this might be a little bit out of scope for our session today, but from what I've seen, or maybe that's a bit outdated, but I think ICP had around 46 data centers around the world. Is that still the case? And are these nodes or these data centers basically what you use for that threshold?
There's now, I think, overall in the network, there are, I think, 1,300 nodes. And these nodes sit in independent data centers. So yeah, there's, I think, not sure the exact number of the data centers, but it's in the hundreds. And these are independent data centers. So there's never a node sitting on Amazon Web Services or Google Cloud or anything like this. One thing we really put a lot of effort into was actually ensuring that these are independent data centers. But the nodes, maybe where you get the 46 number from is, the nodes are like, there are, let's say, 1,300 nodes, but they form into subnets. So these it's a sharded blockchain structure. And those shards basically have different numbers of nodes depending on the level of security that you need. So they go from, let's say, 13 nodes for where you want like super high performance and you're not so concerned about security, and then up to, in the 40s of nodes for when you care a bit more about security.
I mean, that number also was, I think, from 2022. So take it with a grain of salt. Yeah. I mean, what I really like about your approach to smart contracts, or as you call it on ICP, canisters, right? It's a different approach in terms of, from my understanding, Cosmos, Polkadot, it feels more like asset interoperability, right? It's more kind of it's easier to move liquidity from one network to another. Layer 0 was more kind of the communication protocol from one network to another. And you basically went like one layer below as well, just like many of these protocols too. But you have that unified approach of, you can directly just engage with all these networks in a programmatic manner. Doesn't mean like that you need to bridge funds on one network to another, but you really can apply logic between those two. And Oh, sorry. Did you want to add something here?
No, I was going to commend you on getting it so clearly. Yes.
Thank you. I'm just wondering in terms of security, as you can imagine, because every network has its own consensus mechanism usually, or how, like, certain specifics of how it works. And as I've seen, you are integrating networks one by one right now. I'm not sure about that because you mentioned that you are integrating Solana right now. How do you try to deal with these things, especially in regards of layer twos maybe, that have certain limitations in terms of finality?
So, super interesting question. I like to think about this a lot. And for me, the nice thing is that actually we don't care. I mean, it's not our problem, it's their problem. So in a sense, I kind of follow along from where you go. Like a canister, maybe I give you some context. It's called a canister. We call it a canister because it doesn't just have the code. It's not just a contract. It also holds the state. So we kind of say that we package the code and the state together in this canister. This is why we give it a different name. But so a smart contract, let's just call it this for now because it's easier. They can hold, let's say, Bitcoin or Ethereum natively. So when a smart contract has control over Bitcoin, it has a Bitcoin key and it writes to the Bitcoin network. And that means all the things that come with the Bitcoin network. So it means that if you make a transaction, or if the smart contract makes a transaction, that transaction goes through the normal Bitcoin consensus as a normal Bitcoin transaction does. And you have to pay the normal Bitcoin fees and wait the time that it takes for the block to be mined and finalized. So it's usually slow and it's usually expensive, but you get the Bitcoin security or the Bitcoin consensus. And it's the same for Ethereum. If a smart contract makes an Ethereum transaction, it's the same. It goes through Ethereum consensus and it goes through the Ethereum fees and the finalization and latency, whatever. For L2s, it's pretty interesting because we do actually already have some L2 integrations. This came recently in the last few weeks. But say, for example, I want to do a transaction on Arbitrum or Optimism. They have their ways of processing transactions. Maybe they don't have consensus yet. Maybe they don't have fraud proofs yet. Maybe they don't have ways to challenge fraudulent things yet. But as a transaction that goes to Bitcoin goes through the Bitcoin consensus, anything that goes, like if a smart contract makes a transaction to, let's say, an Ethereum L2, it will be treated the same as any other transaction on the Ethereum L2. So if you trust that the Ethereum L2 does its thing, sends the transaction to Ethereum then, and it later gets verified, it's the same. So for us, maybe you hear the term chain abstraction. Like we literally abstract away all of this kind of stuff from the particular smart contract because it's not needed. If you want to interact with Ethereum or an L2 or Bitcoin, you take the good and bad that comes along with that.
Or from my understanding, for the application developer, that means they have the responsibility of dealing with and understanding the underlying consensus of each network they engage with, basically. Is that correct?
Yeah, exactly. So if they want to, I mean, from my understanding, I mean, a lot of the developers that I talk to, they don't necessarily care so much about the underlying consensus. I think like people used to care about consensus a lot, but I think now the focus is a lot more on whether it works rather than how it works. And I think people use different blockchains like Ethereum or their L2s for other reasons like, scalability, speed, liquidity, community, vibes, whatever, memes, as it may be these days a lot. But yeah, I think if any developer makes the decision that they're comfortable with using L2s, here it's the same. Like you have a smart contract that can integrate with an L2, and you have the same guarantees as integrating directly. So yeah, I don't know. Do you I'm curious? Do you find that developers care about consensus and how things actually work?
Less about that part, but I'm just thinking about the unusual case that if, so, for example, a chain is rolled back, a network is rolled back in case of a reorg, for example, right? And since that could be the case on rollups, for example, that's just something I wondered about. Like if you're dealing with that in some sense, or if basically the application developer just needs to make sure they wait a certain amount of confirmations or something like that.
I see. Okay, I see a bit better. I think, like for me, let's say interacting with an L2 as a smart contract on ICP or whatever, you can see it like interacting with an L2 as a wallet or as an account. So if transactions are rolled back, let's say I'm just an end user with a wallet, if my transactions are rolled back somehow, it'll appear in my wallet that the transaction is rolled back. It will be the same for the smart contract. For Bitcoin, there are some design decisions. So this is a little bit different. If you build applications on ICP, and so you have all this programmability around, I see where you're going with the question now a bit more. So yeah, if you build some functionality around using these transactions, then yeah, you have some choices to make. So like with Bitcoin, for example, do you wait for 12 finalizations as a standard, or do you take the risk and just wait for 1 or 2? This kind of thing. This also applies. It's the same. It's interacting with an L2. Do you wait a week until you allow people to withdraw? It should be the same. I think that's the good, the bad, and the ugly of it. Like it's as if you are dealing directly with the L2 or the particular L1, whatever it might be.
I don't consider it something bad, right? There are bridges out there that ignore it as well. So it's just in terms of UX, right? What do people want and need, as you mentioned before? And people want to have ease of use more than hardcore security. And in the end, it's a decision they make themselves.
So yeah, if you're a smart contract developer and you have, so one of the things I'm trying to really encourage at the moment is if you have, let's say, an Ethereum smart contract or an Ethereum app or L2 dApp, that maybe, ICP has all these special features that make it super nice to use. And everything is decentralized, as I said. So if you want to maybe decentralize some part of the stack, you can just use some ICP features to augment your existing Ethereum app. And there, I think you will already be used to the dealing with like Ethereum or the L2 or Bitcoin, whatever. But if you use the smart contract, then exactly, there are design decisions that can be made. And so for example, we recently integrated USDC. So we have now USDC, like a USDC clone on ICP. And there the fees are paid. Like, so when you transfer this, the fees are paid in USDC. So you don't have to pay the fees in ETH. You don't have to hold multiple currencies. You don't have to go back through the L1, this kind of thing. So this was something we developed at DFINITY. And like with this usability question in mind, actually decided, okay, the fees should be paid in the same currency. You don't have to hold two currencies to move it around. And so this is a design decision that's up to the developer. So I guess ultimately full flexibility is there. Like it's as if you would interact with the blockchain natively. So you make all the good and bad decisions that you like. So yeah, if you want usability, you can build it in.
Brings me now to not so recent, but still somewhat recent development, account abstraction. On the website, it's mentioned in regards of or related to chain fusion that you some kind of able of developing a smart wallet, if I understood it correctly. Would you mind putting us through like what's different to general account abstraction? What's special? Like what's the awesome and cool stuff about it?
Well, define account abstraction. I think everyone will have a different view of this. But I think for me, for the large part, it's the same intuitively as everybody understands account abstraction. It's the nice thing here is that, as I said, a smart contract can hold Bitcoin, Ethereum, ICP, whatever, and can interact with them natively. So can pay the fees and wait the time if they want to do that natively. But they can also leverage the ICP features if they want to have fast and cheap and whatever usability transfers, more user-friendly transfers. But how does it go? I mean, so any smart contract can have a Bitcoin address, an Ethereum address, and actually any smart contract can have all of those addresses. And so immediately it becomes clear that this is essentially a wallet. All you need to do then is just keep track of the balances, and this is it. Because we have this sort of full stack decentralization, these wallets or smart contracts that hold coins and have addresses can also have a web interface. So you can, like, from the smart contract also serve web content. So it means that a user can have an actual interface, like a web page that is the access to their wallet. And so for me, this is like the key thing to account abstraction. So I don't need a plugin in my browser. I don't need I don't need to download an app from an app store. I just access from the internet or from a terminal if I'm so inclined to access my wallet, which is directly just a smart contract. But this is it. So for me, it's just having the wallet as a smart contract with some sort of interface instead of needing extensions or downloading apps.
Love it. What do you personally think? What's the most exciting or what has the highest upside potential in terms of what Chain Fusion enables?
So for me, personally, I don't know.
And sharing that, of course.
Yeah, no, I don't mind. So I don't know. I go through all the phases with all the blockchain industry. Like in 2019 and 20, I was going through the DeFi summers and like learning about yield farming and this kind of stuff. In 2021, I got big into NFTs and made lots of friends and did lots of trading there. So I really like that. Now with Chain Fusion, one thing that I like, there are multiple things. This could go on a while, but one of the main things I like is that it's also, I mean, it's not just because of Chain Fusion, it's also like the Bitcoin narrative kind of kicked off at the end of last year. The Solana meme coins kind of kicked off at the start of this year. Chain Fusion now, there are a lot of developers kind of migrating to ICP to build their protocols there. What is super exciting about all of these things is that the tribalism is going. Like, I really didn't like that people were like, I only work on ETH. Like, unless if this is not an ETH NFT, I don't care. Who cares about Tezos NFTs or this kind of stuff? I was like, but like, it's cool. Like, I mean, it's all cool. Like, I don't see why, and of course, Ethereum has much more value. So maybe Ethereum, and maybe it's more secure somehow. I don't know. Like, people come up with all these kind of excuses and reasons why this one is better. But I think this is changing now. Like, as I said, with the Bitcoin thing, you see Ethereum people at the Bitcoin conferences and Solana builders looking at near protocols. And as I said, people are migrating to ICP, and it's like, it's all a bit more fluid. And it's like, okay, we're reaching a certain level of maturity that we can all appreciate that each of these tech stacks, or like building blocks even, they're not even full tech stacks often, it's just pieces of the puzzle. All of them are cool, and all of them have different properties that make them great. And I really like that. The tribalism is dying a bit. Another thing, maybe, I don't know if it's so much about Chain Fusion, but I think one thing that I really expected to kick off after the NFT phase was around DAOs. I think then, like during the NFT craze, some DAOs started to form around management or investment or whatever, like just some sort of shared control over a wallet, let's say. I mean, it was nothing fancy at the time. But now, I mean, the DAO infrastructure is getting much more advanced, and I think like a lot of kind of, let's say, companies that are starting to build on Web3, or the more mature ones, are going down the DAO route. So for me, it's super interesting to see how DAOs will evolve with this sort of chain fusion era, or this era of less tribalism, because maybe one of the things I think is super cool is, let's say, Uniswap, for example. Uniswap is like obviously a very prominent DeFi protocol, one of the most prominent, and they very much, I think, favor decentralization. And they had this DAO, and they had this huge token airdrop where they got lots of people in the DAO essentially, and they take governance very seriously. And I really like that. I think that's great. But now Uniswap becomes popular and exists on many chains across mostly EVM chains, let's say. But even then, if you make a change, like if the DAO decides to make a change to the Uniswap protocol, that's fine. They can vote and it can pass. But how does this vote propagate? How does the code actually update? How does the change propagate across all of the chains? If the vote happens on Ethereum, then how does it like resolve on optimism, for example? So there's still a lot of manual work that needs to happen for something like Uniswap. And for me, with this multi-chain, less tribalism era, this can all happen automatically. So it's just a matter of building it and having, let's say, multi-chain DAOs that control huge Web3 apps across all of the chains and manage lots of tokens and NFTs and users and votes and everything across everywhere. So this for me is super exciting.
Quick intermission. If I could ask you for one single favor, it would be that you hit subscribe onto this channel, because it helps our channel more than you can imagine. And the bigger the channel gets, the bigger the guests get. So thank you very much for watching, and let's continue with the episode. You just brought me to a really interesting thought.
Oh.
Basically, internet computer or chain fusion could be some kind of infrastructure as a code, as we do have it on DevOps as well, that you are able, as you mentioned, if you have your network or your protocol on a lot of different networks, that you deploy it in one go on all these networks, conduct these transactions in a streamlined manner, and you don't make any human errors along the way, or you have a centralized control point here. So it actually DAOs and managing networks as our protocols across networks could be, in fact, a really interesting painkiller for a lot of these very mature protocols out there.
Exactly. So this is like a huge, goal of ours, I think, in general. Even if it's not a DAO, but even if it's just a centralized organization that wants to deploy smart contracts across different places, the infrastructure is there. We're running cron jobs across different chains and things like this. I think for me, it's super cool. And for the more mature ones, integrating, if you can do Uniswap across Ethereum, all the EVMs, all the L2s, Solana and Bitcoin, like imagine the TVL that you can get. Imagine how powerful this DAO can be. Imagine, like, if you look at the biggest banks in the world. I'm not saying it's going to happen for Uniswap, but like it's kind of happening for Uniswap. So it's like, how is Uniswap or something like Uniswap going to look in the next 10 to 15 years? And people are building banks, people are building neobanks, people are building crypto banks, they're getting licenses. It's becoming much more embedded in the real world. It's not just a crypto thing. And like, how is the management of this going to look? How is all the technical upgrades going to look? For me, this is something super exciting, and to be here at this time and to be involved and to have the chance to be an early sort of contributor and like even an early voter. Just even being a bystander at the moment, you kind of get carried along with the wave. So it's a good time to be here.
Corporate is entering the room, or did enter the room already. So for better and worse, of course.
Yeah, we try to put our stake in the ground before they take away our nice tools. But
Sure. I mean, part of the game, right? That means it's actually working, right? So the goal was never to keep enterprise completely out of that space, I hope, right? Because otherwise you will never, also the space would never evolve to anything that has some kind of mass adoption, right? You need it.
I remember once seeing, I'm based in Zurich, I saw a talk from a guy at PostFinance, like a bank in Zurich, talking about Bitcoin, like custody and management. And they were now like, if you have an account there, you can store your Bitcoins there. And I was like, whoa, mister, why are you coming? Not why are you? I'm also guilty of being a bit tribal sometimes about Web3 and crypto, but I was like, why would you even bother? Like, I mean, we don't need you. And he was like, you don't need me because you're a cryptographer, like you build this stuff. But like, if you want your mom to start using this stuff, like people are buying Bitcoin instead of gold now. Like, do you think they know how to store gold securely? No, I mean, the banks exist not purely to cause like, not purely to be like malicious in the world, and like they're not all bad. They do actually provide a service. They're not all corrupt, and they do help. They're there for a reason. And yeah, maybe not perfect, but that same reason is going to serve Bitcoin customers. They want someone to manage it. They want someone behind the desk. They want someone to call when their keys somehow are not working or whatever. And I was like, yeah, it's true. I mean, yeah. So I do see very much the value. And like, if they agree with the principles, and like if they like, I mean, I think it seems to be that way. It's not all bad. It's not all corruption. It's not all, oh, let's just jump on the bandwagon. It's like, no, this is a useful thing, and we're going to use it as well as you use it. So
you nailed it. Basically, in the end, it's always about what the market wants, right? If you have a lot of people, no coiners, as we used to say, right, that want to enter the crypto market in some sense, then these, let's say, Web 2.5 actors are great. Gateway or abstraction.
Services are needed.
Maybe getting back to chain fusion, because I'm actually curious about that part too. On ICP, I can develop a lot of different, also I can develop smart contracts with a lot of different programming languages. From, how's it called? Motoko?
Yeah.
To Rust, Python, TypeScript, and so on and so forth. And I'm just wondering, like, every programming language as well has its own security guarantees and unique twists. Like, how do you deal with that? Or is it all just compiled through the same bytecode and it doesn't make a difference at all? Like, what is your take on that?
I mean, I think, as you say, it is all compiled. Everything compiles down to WASM. So everything runs, like anything that compiles down to WASM, you can use as a programming language for ICP smart contracts. The security things, yeah, as you say, like they all have their own features and security benefits, or more or less usability trade-offs, let's say. And I think the same applies. I think for me, like as a cryptographer, always simplicity is best. So like whatever you can do in like, a kind of simple and secure way, like with control, then this is easiest to analyze the security. So like with Python, for example, generally with cryptographic stuff or where security is concerned, a lot of the kind of tools are abstracted away from the user to make it easy. And this is good and bad. It's good for usability, but maybe less so good for security sometimes. So the same applies here. I think the majority of the smart contracts developed on ICP are built in Rust. Motoko is our native programming language. It's our own one that we developed. And it's just highly optimized for ICP. So I think a lot of people, let's say at DFINITY or in the Motoko team at least, would argue that this is, one of the best things for security, because it's a very simple programming model specifically for this environment. Otherwise, I think Rust has a lot of kind of nice security features. But yeah, I think the main thing is around efficiency. I think efficiency is much more affected than security by these things.
I just thought every time I hear like let's code a smart contract in TypeScript or JavaScript. It's like, okay. Initial, like, okay. I really like ICP's approach to like try to integrate a lot of different things, right? Different programming languages, different networks. You really try to defragment a very fragmented space. And I'm just wondering in terms of maintenance, because that could become really cumbersome, I guess. Like how I know that's more kind of an organizational kind of thing, but what is your impression? Like, how do you deal with that?
This is such a great question, and it's something that's really not discussed at all. And like, it is a lot of I'm not going to say it's a huge problem. It's fine, but it is a big organizational problem. So, as I said, let's say we integrated this USDC twin a few weeks ago. So we released this token standard on ICP that allows to sort of create twins or wrapped tokens on ICP. And we made USDC, so we had a stable coin, and everybody got very excited. And it was like, finally, DeFi summer can kick off on ICP. And then the community started kind of writing and saying, now that you have the infrastructure in place, why can't we just have like 50 more tokens? Like, why don't you just integrate them all and launch them all? And it's like, well, we could, but someone needs to manage all this. Like, somebody just needs to, is it a lot of management? No, it just means like checking some keys every now and then and like whatever, like making sure that the smart contract has some cycles or gas, whatever you want to call it. It's just a little extra management. And no, it's not hard, but someone has to do it. And there's a kind of lot of debate about who actually manages these things. So inside DFINITY, obviously, there are teams that are dedicated to this kind of stuff. And they're always very cautious anytime I come along and say, yeah, let's integrate 50 meme coins and another 20 chains. And they're like, whoa, like, hold on a minute. But yeah, so I think, what I would love to see, which I think is slowly happening, is that the community gets more responsibility in this respect. So I think sometimes because we are so R&D focused and so security focused, we can be very, like our standards can be very high about what we expect the community to deliver, let's say, or like what sort of good management of even just a small contract, that a small integration, we can be very picky. And I think the community now is becoming a bit more mature. They know ICP, they know how smart contracts work. They know, they know how things work. So I think it's much more likely that smaller, either community members or smaller organizations start to form around the management of these things. So one example of this, not directly related, but not so far away, is this small group of developers in the ecosystem who check, like anytime we make a new release, we release, and then, there's a hash that you can check, and you can check, that everything compiles fine and that we're not, everything is fine. And so they check the new releases, they compile them, they check everything matches, and that they kind of, they check the governance protocol is working fine. And they're called CodeGov. There's a few developers in the ecosystem that, check new releases. And so this was like not a big problem, but it was a similar type of problem about 2 years ago. And this group of developers started to do this. So you see that some of the more knowledgeable developers do eventually come together and say, okay, we're going to manage this side of the organizational management of this network, because, okay, it runs autonomously, but it's still, things in other ecosystems change and everything needs to stay on track and stay up to date. And so sometimes it just needs a little helping hand to check, like, is this still up to date? Do I need to change API keys or anything like this? Some community members start to do it. Some people internally at DFINITY do it. I think more and more we'll see small sort of operational management companies or DAOs forming to do this. But yeah, it's a very good question, and nobody asks it. I think everyone's like too busy chasing the next meme coin or whatever. I don't know, like, but I think it's a very serious question that deserves to be asked more and appreciated. The work of the CodeGov guys who actually do check these releases, I think, is underappreciated, and projects like this are underfunded because they're not so sexy or whatever. But yeah, it's a great question, and I think many people will thank you for raising it.
In the end, every company matures, right? So, and DFINITY is nothing different in that case. And it's, you're still one of the, few projects that are actually still around, not just floating into the abyss and just trying to keep the community somewhat happy, right?
Wow.
So at least from my impression. So that's really cool. And I have one last technical question for you, if that's okay. As a subject matter expert, you are also very deep in privacy from what I have seen. What's the ICP's edge to zero knowledge? Because as an internet computer, of course, that could be in some sense really interesting, from my opinion. What's currently developed on that side? What are you considering? Is that an option at all? What about provers, verifiers? Like, just what you can say and want to say.
The old story, like the old answer to this, was that we don't need zero knowledge, because zero knowledge that's used in the industry now for L2s, for example, has nothing to do with zero knowledge. There's nothing, they don't, like the zero knowledge protocols that are implemented don't give actual zero knowledge guarantees. There's no privacy. The thing that they do guarantee is succinctness of a proof. And so when you generate this proof, you can say, okay, here's short. I can prove to you like a huge amount of information in a very small, quick, easy to verify way. But there's nothing about privacy. It's fully open, fully transparent. Everyone can see everything. And so with this chain key cryptography, let's say the innovation that I mentioned at the beginning of our chat, with this, the internet computer has a single public key with which any interaction with the internet computer can be verified. So like you essentially have a zero knowledge computer for free, because you can verify any interaction, you can verify any transaction against this public key that's sitting on the internet computer. So all transactions are signed and can be verified. So for any of the ways that zero knowledge is used currently in the internet or in Web3, we already do. So we don't need zero knowledge in that regard for scalability or whatever. But given that zero knowledge proofs are used a lot in the industry, it means that they have developed very quickly. They've become much more efficient, and a lot of hype and money went into it because it sounds cool. And I think people expected that there was this privacy element. And so now that they've become more efficient, the people who have implemented them and who are using them maybe start to ask the question, like maybe we can add the privacy guarantees as well. Okay, it's going to make it less efficient again, but we were already used to that. So maybe we can actually do zero knowledge where there are some zero knowledge guarantees. And so now we start to see some projects building on ICP that use zero knowledge. So one example, I think, is called Zcloak, where they built a decentralized verifier. So like if you have a zero knowledge proof, who verifies this quickly? And they've built something to do this. And their end goal essentially is private decentralized identity. And so, yeah, if I want to prove some attributes about myself, I want to prove to you that my Twitter username is this, I can give you a proof and whatever. So they're doing that. There's, decentralized verifiers. There are some people building provers because it became trendy, let's say, and because we have a way to build decentralized stuff with efficiency. And this is a bit unique because I think, it's not so common in the industry. But another thing is now that so let's say the rollups, like the zero knowledge rollups, usually the sequencers for these are centralized. So there's a question then about having decentralized sequencers. How can they work? For us, again, it's like super easy to do because we have an efficient tech stack that can do things like that. So yeah, all these things are coming up. Not so much about using zero knowledge for privacy. I'm absolutely happy to talk about that as well, but it's a little bit of a different topic. But yeah, so there are some zero knowledge things happening on ICP now, more and more, as the people who have implemented zero knowledge protocols need more decentralization. So yeah, that's the take. There's like zero privacy involved in any zero knowledge stuff pretty much in Web3 right now. Okay, there are a few like Zcash and I think Mina, like these are the kind of privacy advocates from before that did zero knowledge in the real way, where it actually gave zero knowledge guarantees, but majority do not. And but there are some projects building decentralized infrastructure for zero knowledge on ICP.
I just remember a couple of CK conferences and things that I attended. There was always this kind of, especially in the beginning, not so insider joke about, we are so sorry for, that CK is being misused across the space, or something around that matter. But yeah.
I should give a little correction, because I remember also being at a ZK conference back in the day, and I remember Jan, who's the CTO at DFINITY, talked. So we do use zero knowledge briefly in some of the internal protocols. So there's like some small zero knowledge proofs going around, but like it's been there since before the launch. It feels like old at this point. It's like not the hype stuff, but yeah, they are there and they are used a bit. But yeah, but it was the same like with cryptography and cryptocurrency. Whenever the blockchain conferences started happening, everyone started talking about crypto and owning cryptos. And all the cryptographers started getting, it means cryptography, and that battle was lost. And so I think ZK no longer, as I said, the privacy aspect starts to come back a bit more now, but yeah, the jokes remain.
Awesome. Thanks, Ash, for leaving all these nuggets here. I really, really enjoyed it. As a last final question, are there 3 things that you want people to remember about this awesome session?
I think we had many nice conversations, so thank you, first of all, for having me. But I think one of the things that I enjoyed the most actually saying today was that the days of tribalism are over. Like, this multi-chain world is here. People are much more open to work across chains, and they only benefit, like everyone benefits from this. So that's one thing. I think another is that, the tech is here, actually. I think a lot of companies and projects kind of say that, in the next 5 years or on our roadmap, we'll do this and we'll do that. We'll decentralize our sequencer, this kind of stuff. It's like, you don't have to wait, like it's here now, so it can be done. And the third is to just start using things like that, dive into the ecosystem, as they say. I think using things is one of the best ways to learn about an ecosystem. And maybe I give you one, I'll tell you about one project if you don't mind, because it's a great way to get into the ecosystem. So there's a project. So you see all the meme stuff that's going around these days, and everything is about memes. And one thing that I loved is that some people are making this meme tech. So I saw an Ethereum project who was making like a meme platform. It's kind of like an NFT marketplace or something like this, but more for memes. And they were calling it meme tech. And there's a meme tech project on ICP called Windows 98. And it's like a whole play on, the Windows 98 operating system, but they've basically replicated the whole Windows 98 operating system on ICP. They have their little desktop and they have like these pixelated apps. And so if you go to Windows 98, if you look, and boot the desktop, you actually have access to all the ICP applications, and they have a meme coin and whatever. But there's like the SocialFi apps, there's the DeFi apps, there's like various different things that are in little games that are in the ecosystem. So I think it's one of the most fun ways to get started and explore. That's my little alpha that people can take away.
Now I somehow see the degen coming out.
Oh no, I managed to hide it so well, but I try. No, but yeah, this is, I mean, for me, it's just fun. And I think it really sums up the ICP ecosystem because, like, as I said many times, like, we really are, like, DFINITY is at least a very R&D heavy organization. We do care so much about the tech, and it's all about the security, and like people complain at us about marketing and things like this. And it's like, you need to get out there more. People don't know about this. And I just find it kind of funny that like one of the biggest projects that comes from the ecosystem is this like meme tech. Like we can't even just do memes. We have to turn the memes into tech. And I find it very funny. But I also think it's quite cool that they host an operating system in a smart contract. Like it's yeah, so it's I just find the whole thing very funny. And like the website is cute as well. So I think they've done a great job.
The website with, I guess, a huge doge on it is so.
Yeah.
No, cool, awesome. Hey, really, thank you again, Ash. Learned a lot, and I really enjoyed this episode. So, thanks everyone for watching, and yeah.
Thank you very much.
Hope you guys liked this episode. So if you did, please leave a comment below. Tell us how you liked it, what we should improve, who we should talk to next. Hit subscribe, hit the like button, whatever. Any engagement helps. Any feedback that we get from you helps. So really thank you for watching the whole episode through, or at least skipping to the end. So thank you very much for your time, and yeah.
WaveAct, the Web3 software company that understands what you want.